Texan Global School. Slope of a line. In this class, the process for obtaining the slope of a straight line is demonstrated and discussed, starting from any 2 points that define a line in the plane. We will deduce the formula to obtain a straight line's slope m, or angular coefficient. We can see that a right triangle is formed with the points P1, P subscript 2, and B, which also defines an angle of inclination alpha formed by P1, P subscript 2, B. As we saw in previous classes, in the trigonometric functions and their ratios, the tangent of the angle is equal to the quotient of the opposite side over the adjacent side. This quotient is the vertical increment over the horizontal increment. It is also the change, represented by the Greek letter delta, in y over the change in x. So the tangent of alpha equals side B, P1 over side P subscript 2, B. Using the formula derived above to obtain the distance of a segment, side B, P1 is y1 minus y2, and side P subscript 2, B, is x1 minus x2. By substituting, the slope of a line, also called the angular coefficient, can be calculated as the tangent of the angle of inclination alpha, or as the quotient of the difference of the ordinates over the difference of the abscisses. This relationship is known as the slope of a line defined by the letter m. Essentially, the slope is a measure of how steeply the line rises or falls as it moves horizontally. The Greek letter delta, represented as a small triangle, is the change in y over the change in x. Let's see a first example. Find the slope and the angle of inclination of a line that passes through the points 1, 1 and -2, -2. First, graph the line on the plane. Now, calculate the slope by substituting y1 equals with 1 and y2 equals with -2. x1 equals 1, x2 equals -2. In this case, results a slope of 1. We can see that the delta y is 1 and the delta x is also equal to 1. That is, it advances horizontally by 1 and goes up by 1. To obtain the angle of inclination, substitute in the formula of m equal with the tangent of the angle alpha. As m, in this case, is equal to 1, isolate the alpha angle as an arctangent of 1. If we remember exact values, the tangent of the angle equal to 1 corresponds to 4 to 5 degrees. Since the slope is 1, the increase in y is the same in x at the points on the line. In this other example, find the slope and the angle of inclination of a line that passes through the points 3, 2 and -3, -2. First, graph the line on the plane. Now, calculate the slope by substituting y1 equals with 2 and y2 equals -2. x1 equals with 3, x2 equals -3. In this case, results a slope of 2/3, approximately 0.67. We can see that the delta y is 2 and the delta x is 3. That is, it advances horizontally 3 and goes up 2 units. To obtain the angle of inclination, substitute in the formula of m equals the tangent of the angle alpha. As m, in this case, is the same with 2/3, isolate alpha as arctangent of 2/3. Using a scientific calculator results an angle of inclination of 33.69 degrees. As the slope is 2/3, the increase in y is 2 for every 3 increase in x in the points of the line. In this last example, find the slope and the angle of inclination of a line that passes through the points -1, 1 and 1, -2. First, graph the line on the plane. Now, calculate the slope by substituting y1 equals 1 and y2 equals -2. x1 equals -1, x2 equals 1. In this case, results in negative slope of -3/2, equal to -1.5. We can see that the delta y is 3 and delta x -2. That is, it advances horizontally to the left, that is, -2, and goes up 3 units. Or move 2 units to the right and goes down 3 units. To obtain the angle of inclination, substitute in the formula of m equals the tangent of alpha. Since m, in this case, is -3/2, isolate alpha as arctangent of -3/2. Using scientific calculator results in an angle of inclination of 123.69 degrees. Remember that the angle of inclination is formed by the positive part of the x-axis and the line when directed upwards. And since the slope is -3/2, means that the increase in y is 3 for every 2 decrease in x in the points of the line. In summary, the slope, or angular coefficient of a straight line, is a measure of how steeply the line rises or falls as it moves horizontally. An acute angle generates a positive slope. An obtuse angle generates a negative slope. A right angle creates a slope that does not exist. That is, a straight line parallel to or on the y-axis. A 0-degree angle generates a zero slope. That is, a parallel line or on the x-axis. Finally, the comparison of the previously drawn lines and their slopes is presented. We can see how the positive lines, by increasing the value of their slope, the inclination increases. In contrast, a negative slope is reversed. And 2 lines with the same slope are parallel, as lines with negative slopes show. A line with a slope that does not exist or is infinite is represented as a parallel line or on the y-axis. A line with zero slope is represented as a parallel line or on the x-axis. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com